information about reasoning skills, so we're going to go through this. The vocabulary is important, though. We're going to learn today about conjuncture, inductive reasoning, and a counterexample. Let's first just take a chance to review, make sure you know how to do these problems. If you need to find the length of a segment with endpoints 1, -3, and -2, -7, you should be able to use the distance formula and get 5. If M is the midpoint of RS and the coordinates of R are such as below, find the coordinates of S. I do find that sometimes we have issues with these problems, so I'm going to go through this one. If I can get my pen to work here. There we go. So we have R, we want to find S. N is the midpoint for -3. You can use the formula, or at this point as we're getting more used to it. If I go from 8 to 4, that is a change in X of -4. Now I minus 4, I subtract another 4, and I get to 0. For my Y values, to get from -2 to -3, Y is losing a value of 1. If Y loses another value of 1, from -3 minus 1 is -4. And so my answer is 0, -4. Line A and line B are supplementary. If the measure of A is 3 times the measure of B, find the measure of B. So A plus B, if they're supplementary, they equal 180. If the measure of A is 3 times the measure of B, so substituting for A, 3B, I have 3B plus B equals 180. 3B plus B equals 4B. If 4B equals 180, 180 divided by 4 is 45. And there's my answer. So in this lesson, I'm skipping example 1 because actually the way it's written in the book, there are some issues with the correctness of number 1. Number 2, though, describing a number pattern. We've done these before in Algebra 1. You can see that the pattern here is -7 to -21 to -63. Each time we are multiplying by 3. You may remember from algebra that's a geometric sequence and you have a common ratio. And so if you take 189 and multiply it by 3, you get -567. Times 3 is 1,701. Times 3 is 5,103. Giving you a guided practice here. You can start to see that here you're adding 2 100ths or 0.02 each time. That's an arithmetic sequence, but you can describe the pattern. In logic, a conjecture is an unproven statement that is based on observations. So you use inductive reasoning when you find a pattern, specific cases, and then you can write a conjecture. It's like the statement for what you think is going to be the case. So let's look at how we make a conjecture. We're given 5 linear points to make a conjecture about the number of ways to connect different pairs of points. So to come up with a conjecture, we're going to make a table. And if we have 1 point, we can say that there's no lines, segments to connect there because it's only 1 point. If we have 2 points, there are 2 points there. I can draw 1 segment. For 3 points, there are actually 3 different line segments I can draw. I can draw from this point to this point. I could draw from this point, the second point to the third point, and I could draw another line. They've made it like a curved line over the top, but to show you I can go from the first point to the third point. If I have 4 points, there's actually 6 different line segments I can draw. So they want you to make a conjecture. So you can connect 5 collinear points, 6 plus 4, or 10 different ways. 6 plus 4 is going to be 10 because they're noticing that the first time it increases by 1. The second time it increases by 2. The third time it increases by 3. The fourth time it increases by 4. That's not an arithmetic or a geometric sequence because there's not a constant rate or ratio of change, but we do still notice a pattern. Now, we can test the conjecture. So numbers such as 3, 4, and 5 are called consecutive integers. We're going to make and test a conjecture about the sum of any 3 consecutive numbers. So if we take 3 plus 4 plus 5, we add them together equals 12. 7 plus 8 plus 9 equals 24. 10 plus 11 plus 12 equals 33. 16 plus 17 plus 18 equals 51. So you may have noticed that if you take the middle term in the consecutive integers and multiply it by 3, you would get the number you were looking for. So our conjecture, our hypothesis, if you will, is the sum of any 3 consecutive integers is 3 times the second number or the middle number. So now you can test your conjecture. For instance, let's try involving a negative. So -1 plus 0 plus 1 still equals 0, which is the same as 0 times 3. There were 3 numbers. 100 plus 101 plus 102 is 303, which is the same as 101, the middle term, times 3. So it looks like the conjecture we've come up with works. Suppose you are given 7 collinear points. Make a conjecture about the number of ways to connect the different pairs of points. So let's go back to our chart here. We had 6 plus 4. So if this continued, change my colors here, then from 5 to 6 would be an increase of 5. And from 6 to 7, that would increase by 6. And if you remember before, our conjecture for 5 points was 6 plus 4. So our conjecture for 7 points would be 6 plus 6, which would be 12. So now suppose you were given 7 collinear points. They want you to make a conjecture about the number of ways to connect different pairs of points. So let's go back to what we did before. And 5 points, there were 10 different connections. So each time, here we would be adding 5, and here we'd be adding 6. So 10 plus 5, so for 6 different points, our conjecture that there would be 15 number of connections. And then for 7 points, our conjecture would be that there would be 21 connections. Now notice, we're not able still to just come up with this out of thin air. We have to go back to simpler problems. We had to go back to what do we do for 1 point, 2 points, 3 points to build upon that example. We're not ready to just come up with conjectures out of thin air. We need to start at very basic problems. So now make and test a conjecture about the signs of the product of any 3 negative integers. Well, you might actually know this. If you multiply a negative times a negative, you get a positive. And then when you multiply by a negative again, you get a negative. But here they have you actually testing it out. So you come up with 3 numbers, you test it, and you see that you get a negative. Now we also have counterexamples. So sometimes a student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. So they came up with the idea that the sum of 2 numbers is always greater than the larger number. So 3 plus 2 is greater than 5. To find a counterexample, you need to find a sum that is less than the larger number. You might be able to do that, but a solution would be involving negatives. Because a counterexample exists, then the conjecture is false. So basically, this is not a true conjecture because we can provide a counterexample, basically a non-example. Well, let's try this out. This is a standardized test practice type question. Which conjecture could a high school athletic director make based upon the graph at the right? More boys played soccer than girls. Well, this graph only talks about girls' soccer participation, so they're not going to be able to use it. More girls are playing soccer today than in 2001. Looks like that's true. More people are playing soccer today than in the past because of the 2000 World Cup games. This, first of all, doesn't say anything about total people playing soccer. It just talks about girls, and it talks nothing about the World Cup. The number of girls playing soccer is more than 2001 than in 2007. Well, the graph talks about that, but that's not a true conjecture from the graph. So the answer would be B. Now, find a counterexample to show the following conjecture is false. So, the value of x squared is always greater than x. In this case, they put in 1/2 for x, and we can see that they got 1/4. So since 1/4 is not greater than 1/2, because the counterexample exists, the conjecture is false. In this guided practice, we're going to use the graph to make a conjecture that could be true. So basically, we're going to use the graph to kind of predict the future. And I would probably say something like that the number of girls registering for soccer is going to continue to increase because it's been increasing so far. You could actually, if you wanted to, mathematically make a line at best fit and come up with a anticipated increase. But at this point, we're not asking you to do this. We're just asking you to come up with logic, makes sense that the number of girls playing soccer will continue to increase based upon the data. So now it's time for the daily homework quiz. Describe the pattern in the numbers, write the next number in the pattern. So you can see here you're increasing by 2, then 3, then 4, then 5. So I'm going to assume that next week we continue increase by 6 and we would be at 40. Once again, notice this is not a geometric or an arithmetic sequence. There is a pattern, though, to this increase. If we were going back to algebra, this pattern would not be linear. We don't need to know that right now. We just need to understand that there is a pattern. Find a counterexample for the following conjecture. If the sum of two numbers is positive, then the two numbers must be positive. So you want to find a counterexample, something that disproves this. See if you're able to do it. Okay? In this case, we found two numbers where one was positive and one was negative, and they made a positive, so the two numbers must be positive. You can actually take a positive and a negative number, add them together, and get a positive. So that's a counterexample. So that proves that they don't always both have to be positive. The scatter plot shows the average number of hours of homework done per week by a student during the 10 weeks of a school year. Make a conjecture that could be true. So come up with something that could be true. I'm going to say that as weeks continue, his or her amount of homework is going to increase. So the student will do 11 hours of homework in week 11 because the number of hours of homework is steadily increasing. Now, obviously, we would hope in the real world that that would eventually taper off, but we are making an assumption based upon data at this point, not including just things that we've experienced. Here are the problems that your homework comes from. Some of you will have difficulty eyeballing and understanding patterns in this section. You need to just try to do your best. I hope you find this helpful.